So this video we're going to talk about average rate of change and instantaneous rate of change. So remember, average rate of change, that's a slope of our secant. Instantaneous rate of change is the slope of our tangent. So you're going to have 2 points here, some starting time like 1, some ending time of 5. And that is our average rate of change. The slope of our secant is equal to the average rate of change. And so that's just your slope formula. That's it. You're going to also get some point 5 comma f of 5 and 1 comma f of 1. And so it's just going to be the slope, f of 5 minus f of 1 over 5 minus 1. That'll give us our average rate of change. Now the instantaneous rate of change, they're going to give you some point, like 1. So at t equals 1. And so at that point, 1 comma f of 1, we're going to want to find the tangent. So instantaneous, the slope of the tangent is our instantaneous rate. Let's try that again. Instantaneous, there we go, rate of change. So if they say find the instantaneous rate of change, they want the limit as h approaches 0 of our value. And if they want the average rate of change, they want just the slope. So let's try one. So position of the particle given by the equation of motion s of t equals t squared minus this, where t is in seconds and s is in meters. Those are important because they're going to tell us our units. Find the average velocity from 2 to 3 seconds. So the first thing you do is you just plug in 2. And then you plug in 3 into our polynomial. So 2 squared, our function, 5, 2 plus 4, and then 3 squared minus 5 times 3 plus 4, and we find out what those are. So negative 2 is also negative 2. So now we can find our slope. So it's negative 2 minus negative 2. And then 3 take away 2, because remember we're just plugging in points. So this would now be 2 negative 2 and 3 negative 2. And so that's 0 over 1, which is 0. So they're saying our average velocity here is 0. And now we need units. So the top, you notice, is our s. S is the top, and so these are s. So each of these is actually meters, and each of these is seconds. So this would become meters, that's our top, per second. So that is our average velocity, 0 meters per second. And so basically what it's saying is at 2 seconds we were at negative 2 meters, and at 3 seconds we were at negative 2 meters. So they didn't change, and so if you didn't change, the average velocity would be 0 meters per second because you didn't go anywhere. But that's not true. So it looks like this. Let me click these off. We're going from 2 to 3, and it doesn't look like it's changing at all, like it's just staying put. That's because I have the steps set at 1. So now if I delete that, you can see that from 2 to 3, it actually went back, and then back to where it is. So it moved to the left and then back to the right. Position didn't change, so average velocity is 0. So to get a better picture of what's going on, what we do is we find the velocity and the speed. Speed is just the absolute value of our velocity. That's it. So find the velocity at 2 seconds. Instantaneous is your velocity. So the slope of a tangent, that is our velocity. So what we're going to do is find a limit of the difference quotient, right? As h approaches 0 of f of x, in this case s. So s of t plus h minus s of t all over h. So all I did was replace f of x with s of t. So let's first find our formula that gives us the average velocity, and then take the limit as h approaches 0. So we're going to find s of t plus h first. And so that would just be plugging in t plus h into our s of t. Okay, so this becomes t squared plus 2th plus h squared minus 5t minus 5h plus 4. And then again, we're going to take s of t plus h, subtract s of t. And that just means to take each of those s of t values, so the t squared, the 5t, and the 4, and remove them from our t plus h. So we're going to subtract them away. And you notice they're exactly the same sign, so everything's canceling perfectly. And what we have left is what we were looking for. And then we divide the whole thing by h, and now we have the slope of our secant. So that would be 2t plus h minus 5. So now we want to find our velocity, and that's our s prime of t. This is our velocity. Okay, and so now we take the limit as h approaches 0 of 2t plus h minus 5, approach at 0, and we end up with 2t minus 5. So now we have a formula for our velocity. That's it right there. And so for our velocity, it's the change in s over the change in t. So if we want to find the velocity at 2 seconds, then what we're going to do is plug in 2 for our time. And this gives us -1. And since our velocity is a change in s over change in t, then we know our change in s is meters, and our change in t is seconds. So it tells us our velocity is -1 meters per second. So our velocity is -1 meters per second. And then our speed is just the absolute value of that. So there's no direction on this. So if you have a negative, that means we would be going left for this. And for our speed, we just say it's 1 meters per second. So if you want to convert a velocity into a speed, you can use the direction and its speed. So you would say that it's going left 1 meters per second. If we're doing up and down, this would be down 1 meters per second. And there you have it. Okay, so one more question here, just to see if you understand what's going on. So what we have here is 2 points, A and B, and we want to know, is our particle going faster at A or at B? And so if you want to see which one has a faster instantaneous velocity, all you have to do is look at the slope of that line. So for blue, right there, you could think of that one as a positive slope. So like, that looks like about a 1, like a 1 meter per second. And then at red, right there, you can see that that is a horizontal. And if you remember the slope of a horizontal line, the slope of a horizontal is 0. So this would be 0 meters per second. So what we're saying here is our velocity, instantaneous velocity, would be 0 meters per second for that one, and 1 meter per second for that one, which means that A is faster. So putting all this together, that just means that when you see f prime of A, we're saying that f prime of A is the instantaneous velocity of the particle at time A. So it's literally like a little radar detector hitting that object. So at that moment, that's your velocity.